An introduction into common separating techniques used on the Earth today to get various natural resources such as fresh water, iron, gravel, sugar, gold, salt, and crude oil. And these all have very specific properties. Now, all of the methods you're about to see rely on very specific properties. Okay, our first one is called sieving. Now this works identically to sieving in the kitchen. So it's based on particle size, and you get a sieve, which is your netted structure, and you put your material on top of it. Now, let's say we're getting gravel and sand, so that's going to be the gravel, that's going to be the sand. So we tip it on, and we want to get the gravel. So the gravel is larger than the sand, so it's going to stop on top of it and let the sand fall through. Then we just collect that and we're all good. This works very well, although there's one problem with this, as in nature variations do occur. And in this example, just imagine some gravel definitely will be smaller than this size and some sand will definitely be larger. So we can actually catch sand and lose gravel. But on the whole, it's quite accurate. It's used in mining mainly for, as we just said, sand and gravel. Okay, this next one, also using particle size, is sedimentation. Right, so it's used in gold mining, and the way this works is you get your container and you put your solvent in it. So a solvent is just anything dissolved in water, and you're going to spin it around, and due to centrifugal force, the heavier material will collect on the sides and the bottom. Obviously, if you spin it that way, if you're going to spin it like that way or like that way, it's not going to work. But if you spin it normally, that's what will happen. And the lighter material just kind of congregate near the top because it's less dense, and you just remove that and get your heavier material. Works very well. Okay, so this next one is magnetism. Quite obviously, it's based on magnetic properties. And it's used in iron mining and metal reclamation. So a bunch of junk, and you remove all the iron and you can reuse it. So obviously magnetic properties. So iron is pretty much all it's used for, because iron's the main magnetic element you'll find. So you put the solution in a container. So this one will just be iron and sand, which isn't actually a solution, it's a mixture, but that doesn't matter. You put a magnet over. Normally they use an electromagnet because it has the ability to turn on and off by applying an electrical charge. So you turn it on, and the magnetic iron will just stick to the roof, and they remove this, turn it off, collect it all, and you're good to go. It's used very frequently to reclaim iron, and it is effective. Okay, this next one is filtration. You will see this commonly to get your drinking water. It's also based on particle size. Now, just observe the diagram. The way this works is you get your container with your original mixture. You pour it in to a filter. Now, the filter will stop solid residue. So imagine this stuff is water from a creek. Bits of debris, bits of matter, that kind of stuff. So it stops all this stuff we don't want, and it lets the clean water fall through, and that's what we get. Of course, you can get solids which are small and can slip through, so the varying size of the filter and its accuracy is very important, but it works very well. Okay, this next one's a bit complicated, so you might have to bear with me a bit. This is called fractional distillation. It's used to separate crude oil, and it's used in the industry quite a lot. Now, this is based on boiling points, which is the process of a liquid turning into a gas. Out of interest, solid to a gas is sublimation, but this is just for liquid to gas. So you get your crude oil, your raw crude, you dig out of the ground, and you put it in this chamber and you start heating it. Now, all these materials are the result of this, but they all have different boiling temperatures. So the stuff at the top has a lower boiling temperature, so closer to zero, and the one at the bottom, such as the fuel oil, has a higher one. So you start boiling it, and the temperature rises, and slowly these materials start occurring. So let's imagine we're boiling it, and the gas occurs and it flies up and into here, and now we have gas. Normally that's ethanol and those kind of fuels. This next one, gasoline, again, it has a slightly higher temperature, and gaseous gasoline will come in, and fine, comes down kerosene, diesel, and then fuel oil, which will have the highest boiling temperature, and that just comes in this lower one. There's residue at the bottom, and that's used as bitumen in your roads. It's used very well, very effective. Okay, this next one is distillation, very similar to the last one. Again, based on different boiling points. Now, the difference of this one, unlike fractional distillation to a degree, this needs quite a lengthy separation in boiling temperatures. So you can't have, in this liquid, one which has a boiling temperature of 100 and one which has one of 105. It doesn't work. It needs to have 10 degrees separation. You'd use it to get fresh water from seawater. So the way this works, you have your little apparatus here and your container. You start heating it. You use a Bunsen burner in the lab, but obviously in industry they won't use a Bunsen burner. It turns into a vapor. Now around here is a cooler environment because the cool water allows it to be quite cool, and it condenses into a liquid, gas to a liquid. This then comes down here through this thing called the liquid condenser, and then forms into another test tube or container called the distillate. So this stuff, your remainder, is called the distillate, and that's the stuff we want. It works quite well. Okay, this last one is called evaporation and is very, very common. You can observe it when you look at any body of water. If you leave a drink outside and you come back an hour later and some of it's gone, that's evaporation. Okay, so it's based on boiling temperatures and different boiling points, and you'd use it to get salt from salt water. So you get table salt using evaporation. So the way this works, you have a container. This is just a laboratory experiment of it. You can use any container, and you can even use the sun as the heating. So let's imagine we have the Bunsen burner, boiling it up, and this is a solvent. Let's say it's sodium chloride, just table salt dissolved in water. Starts boiling. Now the water, the H2O, will then turn into a gas and evaporate, and then it will leave our salt solution at the bottom, and we take that and we're good to go. Okay, so this has been a brief introduction into very common separating techniques and the materials taken from them, and more importantly the properties required for these to work. Hope you enjoyed. Thank you.